Hi everybody, this is Mathman, and as promised, we are going to take a look at the derivatives of the last three trigonometric functions, the inverse of the last three trigonometric functions, the arcsine, or ArcCosecant, the ArcCosecant, and the ArcCotangent. And in these in the working out of these problems, I made a mistake on one of the problems, which I corrected in the video. I think there's a benefit to seeing the mistake because I believe these are mistakes that you really need to be careful about in order to get the right solution. So I left it in. I showed you how I found it and corrected it, and then I went about to solving the problem in the correct manner. And so I do think that there's some benefit in leaving it. Again, I'm a little iffy on the technology side. I'm using this Astropad link and a screen capture to uh, get these videos, and so I um, I hope it is legible enough. My penmanship isn't great, and I'm not certain if it has anything to do with this pencil. This is one of the older Apple pencils, and I'm using Paint instead of some other software. So I don't know if another piece of software would be better or not. But anyway, I'm using what I've got, and I do believe you can follow it fairly well. So anyway, if you have any trouble with any of the problems that I've approached and solved, please let me know. I do go through these on a step-by-step basis and should be pretty easy to follow. Look, you're not going to memorize this stuff. You just can't. If you're going to derive it, when you get into a test situation, let's say in college, you're not going to have a book. You're not going to have a cheat sheet. Um, you're going to need to be able to work from first principles to the desired outcome. So that's the approach I'm taking with these. So anyway, this is Mathman, and I wish you the best, and I hope that you're able to follow the following derivations well enough. So here goes. And so now let's get started. Uh, we've been doing um, derivatives of inverse functions, trigonometric functions, okay? So let's take a look at what have we done? We've done the cosine of x. We've done the sine of x. We've done the tangent of x. So what do we have left? We have secant, secant x, cosecant of x, and cotangent of x. And we're going to use this notation for the arcsine. So select all and cut. And so what we're going to do is we're going to leave we're going to do our secant function. So let's say secant, whoops. Oh, I wonder what happened there. Just a second. Pencil, finger, draw. All right. Wonder what happened there. I'm going to choose pencil. 9. Oh, fine. Okay. We undo that. Sorry about that, guys. Don't know what happened there. Okay, so we're going to say theta is equal to the secant, the ArcSecant of x, which means that the secant of theta is equal to x. So we draw our triangle. And we have theta. And secant of theta is 1 over the cosine of theta. And so if secant is x, then that's x, that's 1, and that's 1 minus x squared. So now we've got x equals secant theta, which is basically cosine of theta to the -1 power. So if we want dx, I wonder what the problem is here. Dx d theta of secant of theta equals -1 cosine -2 times negative sine of theta. And so that is tangent theta secant theta dx d theta. And so this is equal to, well, secant theta is x, tangent theta is 1 minus x squared, and so d theta dx is equal to 1 over x times the square root of 1 minus x squared. And that's the derivative of the secant function. And again, I used electronic technology, and it seems to be working out well. So we'll call it quits at this point, and we'll look at the other two functions in a little bit. Okay, so we're going to take a look at the other trigonometric functions. We're going to look at theta. Theta equals cosecant of x. We go to our little triangle, and we have x. Well, the x, let's see, whoops, we lost the screen for some reason. Let's see, we've got x, something funky with this thing. I don't know why it's doing that, but let's maybe put it down on a solid table. And let's see. So we have a cosecant of theta equals x. So cosecant of theta is the 1 over the sine of theta. And 1 over the sine of theta would be, well, x. So that means this here, this is x, that's 1, and that would be x squared minus 1, because this is theta. Because sine of theta would be 1 over x. So, I don't know why this is doing this. This is very bizarre. My screen is cutting out on me. Alrighty. So, now, I don't know what it is, why it's doing this. Okay, so, if that's the case, then we have our triangle written properly, and we have x equals cosecant of theta, which is equal to sine 1 over sine of theta. And dx d theta is equal to d theta of this, which would be minus sine squared theta cosine of theta. And that is equal to minus cotangent of theta cosecant of theta. And the cotangent of theta is this. We got to put a minus sign there. X squared minus 1. And cosecant is x. So if we flip this over, d theta dx, that's equal to minus 1 over x times the square root of x squared minus 1. And that, when you check online, is indeed the value or the result you get when you take the derivative of the inverse cosine. And I'm sorry, I forgot to put the inverse sign there. And so that's how we derive that. I apologize up here. I should have had the arc sign up there. One little thing, when you check online, you're going to see that this x right there is often written like this. And what that means is that x is always positive. In other words, in all practicality, that is x squared square root, which is always a positive number. It's always positive. All right, what's going on with this AstroPad? Going crazy on me. So that's always positive. Always. So that's the derivative of the cosine, or the ArcCosecant of x. Now we're going to take a look at the cotangent, and I think that does it. That does the does it for all 6 of our trigonometric functions. So we start out with let's see, this thing changed. Okay, we got theta equals cotangent, ArcCotan. I'm not going to make that mistake again, of x, and we have theta cosine or cotangent of theta equals x, and cotangent theta equals cosine of theta over the sine of theta. And that means that when we draw our little triangle, boy, this thing keeps cutting out on me. I don't know what's going on. Okay, we've got our right triangle. Something's funky here. Maybe it's the pen. Maybe the pen's doing this. There we go. And that's going to be x over 1. And so this has to be x squared plus 1 square root. So let's take a look at, well, we've got x equals cosine theta over sine theta, and dx d theta is equal to minus sine theta over sine theta minus cosine theta times sine, the minus squared theta, cos theta. And that is equal to minus cosecant squared theta. If we look at our trigonometric identities, we remember that sine squared x plus cosine squared x equals 1. And if we divide, we end up here. This is the cotangent. So we want to divide by sine squared x, sine squared x, sine squared x, and we have 1 plus cotangent squared x equals cosecant squared x. And because everything's negative up here, it's the minus cosecant squared. So, what is the cosecant squared? Cosecant squared is 1 over, well, we got minus 1 over the sine squared theta. And sine squared theta equals 1 minus 1 over x squared plus 1. But we're flipping this. Remember, we're looking for d theta dx, which is equal to d dx of cotangent, the arccotangent of x, and that is equal to minus x squared plus 1. And now if we check online, let's see if we got ourselves the correct result. See if I did this correctly. We will just take a little tour on the internet. The derivatives of inverse trigonometric functions, and we should have them right there. And this guy should give us, oops, let's not go to that one. That's not a, we probably, there we go. There we go. Now, this is it, ArcCotangent. And there we go. Let's see, I had done something wrong. So we will have to do this again. It is negative. Let's see. The ArcCosecant, let's see, ArcCosecant, we worked out, I believe, correctly. It's the ArcCotangent that we didn't do correctly. So where was my error? So we got to go back and take a look and see where my error was. We said that x equals cosine over sine, so x is over 1. So these should be correct. This should be correct. This is right, so we have minus cosecant squared. Oh, let's see. I did this. This is where I went wrong. Right there. Okay, so we will cut this portion. And I don't know, let's see, select freeform selection. So we will and cut. We'll also freeform select this. And we will cut. Hey, this is pretty cool. I haven't done this before. All right. So we're back to pen, and we got our size 9. Okay. So the cosecant of theta is this. Oh, come on now. Let's get the pen to work. Is x squared plus 1. But we have to have the negative sign there because we have minus cosecant. And then when we flip the theta dx is equal to minus 1 over the square root of x squared plus 1. And that, before I do something, there was another error that I made. We got a square here, so that's squared, so that's equal to minus x squared plus 1. So now I gotta do another select, freeform select. And cut. And that equals. Now we gotta do the, darn it. We gotta select pencil. That's the only part that I have to keep remembering. Okay, so that's d theta dx, which is just that flipped, which means we have minus 1 over x squared plus 1. And that should be our, ta-da, let's go back and just square ourselves away. Make sure. Cancel. I just wanted to, I didn't want to erase it. Okay. So let's go back to our cotangent. Let's see, that's arcsine, ArcCosine, ArcTan, ArcCotangent, and here we go. That's exactly what we got. This right here is exactly what we derived in, and it took us a little while, but that's exactly what we got. And we don't need the ta-da actually, so we can freeform select and get rid of that. So here we've got our answer, and we have looked at all six trig functions. And their inverse. So we've done it. We've derived all six of the derivatives for the inverse trigonometric functions. So I think I'm going to call it quits at this point. And but I think it's pretty neat. The tricks, as you can see, are getting that right. And the way you get that is by going back to the definitions and then taking the derivatives and then equating them back to the rectangular or the triangular form, and then flipping this. This is basically the inverse. That's 1 over dx d theta. That's what this is. And that's how we got that answer, and that's how we got all those answers. So I hope this wasn't too bad for you to follow. I did make a mistake, but I was able to correct it. And you know what? Sometimes mistakes discovered while you're showing how to do something is good, because you're liable to make the same mistake, let's say on a test, or let's say you're doing some work, and you know, it's good to see the kinds of mistakes that can be made, and this actually is the real critical part of the whole thing. So getting that right is critical to getting the right answer. So I hope that this has been instructional, even my mistake. We did go back and we confirmed my solutions, and trust me, I was working these out on my own. It's probably been, I don't know, maybe 10 years since I last looked at this. So you can see that my instructor from 30 years ago, Dr. Charles Pine, he gave me the tools to remember how to approach the problem, and then I was able to work them out from using those basic understandings that he instilled. And yes, I did make an error in the cotangent, but I saw that it was incorrect and worked it out properly, and found out the reason why. And these are the types of mistakes that can be easily made by anybody. So I wish you all the best, and we'll take a look at more mathematics in the near future.